At this time, I'd like to introduce our first presenter, Charlie Hughes. Charlie is Key Projects Manager for AFMG. Charlie, take it away.
Thank you, David. I want to welcome everyone to the webinar this afternoon. I'm going to go through a brief introduction of EASE Evac, and then we'll get into actually using the program to do some drawings and map SPL and some other metrics. First of all, I want to point out the version of the program that we're using. This is version 1.1.1, subversion 159. If you have purchased the program and don't have this latest up-to-date version, it's a good idea to download the most recent version. It is available at no cost to those who have already purchased the program. EASE Evac is very useful for drawing two-dimensional plots, plan view of rooms, placing ceiling or wall loudspeakers in the room, and then mapping the SPL within that room. One can also assign surface materials to the walls, ceilings, and floors very similar to that have very similar acoustical attributes to the actual surfaces that are in the room, and that helps determine what the reverberation is within the room. That reverberation, coupled with any external ambient noise, will allow EASE Evac to calculate speech intelligibility metrics such as STI, CIS, or %alcons. We'll get into the drawings and some of those in a little bit, but first I want to show you some of the layout of Evac. Right now we're on the Project tab. On this tab you can enter a title for the project, author's name, and any notes about a particular project that you may have. Next we have the Room tab, and there'll be as many room tabs as there are rooms within a given project. A project can have multiple rooms, which is very useful for, say, laying out an entire floor of a building. You can label the different rooms, which comes in very handy to be able to identify them later on. You can also set things such as the room height within the room, the ear height for the listeners in the room to emulate a standing or seated position. You can also see the vertices within the room that define this. The next tab is an Auto Arrange tab, which can be used to automatically arrange the sound sources, i.e. the loudspeakers, within the room. The following tab actually shows you sound sources that you've placed in the room or that have been placed in automatically, and one can actually change the location or various other properties of each of the sound sources independently. We can also specify room materials for our different surfaces. Here on the Surfaces tab we see that we have a floor, ceiling, and 4 walls, and all the surfaces can be defined here. Next we have the Objects tab. In Bruce's section of the presentation he'll go over inserting objects in the room and tell a little bit more about those. Those are basically all the tabs needed to define the project. Now the remaining tabs actually help show the results of the calculations that EASE Evac does. In this pane here we're seeing an SPL map of the room. You can see we have 5 ceiling loudspeakers and the SPL that they're generating at the defined ear height. Below we're seeing the frequency response at a particular listener location defined right here. And that can be moved, so you can see how the frequency response changes as it's moved around. We can also look at a distribution of the SPL within a particular room. This can be very helpful in determining what our SPL is over a given percentage of the audience area. Lastly, we have a front view, and if we've selected a wall, then we can actually look at the front view of that wall as if we were located in the room and looking at that wall. If we have a loudspeaker selected, we can see a side view of the loudspeaker and the SPL map that's showing there. If I turn off the map, you can kind of see the coverage cone from the loudspeaker, where it intersects the ear height, and this circle defines the intersection of that coverage cone of the loudspeaker at the ear height. Just a couple of things I want to make mention of before we actually get into some of the drawing tools of EVAC. And one of the things is absorption coefficient. In acoustics, we use absorption coefficient to help define the acoustical properties of different surface materials, whether they're wall materials, floor materials. And absorption coefficient is a frequency-dependent thing. Here we'll look at the absorption coefficient of some generic carpet that's placed on a commercial concrete floor. You can see at low frequencies, it's not very absorptive, meaning it's very reflective. At higher frequencies, it's more absorptive, so it helps damp energy in the room at these higher frequencies. The higher the absorption is within a room, typically the less reverberation time we have in the room. Reverberation time is something that we try to minimize in most cases because too high of a reverberation time can adversely affect speech intelligibility. One of the metrics we'll cover today is STI, or Speech Transmission Index, and that's a metric of potential speech intelligibility. To really boil STI down into simple terms, it's really nothing more than a signal-to-noise ratio. The signal being the intended voice message that needs to be heard from a loudspeaker system, and the noise is everything else, whether it's ambient noise from an air handling system, trucks going by outside, or the noise could also be the reverberation of that signal bouncing off walls, ceilings, and floors. So now we hopefully have a basis of understanding about what intelligibility is and some basics of the layout of the program. One other thing I want to point out is the main options of EVAC, and that can be found under File and Options, or at any time you can hit the F9 button, and that will take you directly to the options. There are some project defaults that you'll probably want to do and set up when you start using EVAC. One of the things you can do is type your name, your company name, set a standard room height if most of the rooms that you'll be working with are the same height, and also a standard ear height, so you'll have to change it less frequently. Another thing you'll probably want to do is look at the network. If you'll be dealing primarily with 70-volt systems, you'll want to select it. If you deal more with 25 or 100-volt systems, you can select those. In its default mode, when EVAC's first started, before this is changed, it's going to default to low impedance, which is a direct connection to the voice coil of the loudspeaker. The other one that you may want to change is the environment options. Today we're going to work in imperial units as opposed to metric units, so I'll go ahead and change that. And we'll also work with a 70-volt system. So I'll click on OK there. And now let's start a new project. And we're going to call this project the System Sensor Assembly Room. And this room we'll just call Assembly Room. It'll be the first room. Now this room is not going to have a room height of 15 feet. Instead, we're going to have a room height of 20 feet. But our ear height is going to remain the same. This is 5.5 feet is a typical standing ear height. Now as you can see here, the default room is just a rectangular box, and that's fine for our starting point. But the room we want to draw is actually a little bit more complex than that. one of the neat features of EVAC is you can actually import a background image to use to help draw your room. The first thing we're going to do is import an image file. There are many types of files that are supported. For image files, there are PNG, JPEG, GIFs, bitmaps, or TIFFs. If we wanted to import a CAD file, which we'll do in a little bit, you can do that as a DXF, a Sketchup, or as an EASE project file. But right now we're going to import a PNG image of the assembly room. And you can see this image in our main window of the dialog box. Over on the left-hand side, you can see a zoomed-in portion right around where my cursor is. That's very useful for getting these A and B icons that we see down at the bottom here positioned properly. Now we have to position those because since this is an image file, it contains no information about scale or distances. I'm going to take this A icon and I'm going to move it to the front corner of the room and drop it there. Then I'm going to go get the B icon and drag it to the opposite side. Now we've placed two points within our image. Now we just have to tell EVAC the location of those points. Now this room is 80 feet wide at the front, so our X dimension is going to be minus 40 feet. And we want the Y dimension to be 0 right at the front, so we'll enter 0 there. That'll put our origin right at the front of the room. As I mentioned, the total length of that line, being the width of the room, is 80 feet. So I can click on OK and check it so it will actually show that ceiling map. And then I can use my zoom out tool, this magnifying glass with a minus sign on it, to click that and zoom out so we can actually see that image map. I can also grab the model with my hand and move it around so I can position it wherever it's convenient. Now let's also import a CAD file, so we'll see how that works. Hit the select button under the floor map, and this time we're going to import an EASE project file of the exact same assembly room. Looks very similar. Now you can see there's some things that are not on here that were on the other Edit Layout Map dialog box, namely those A and B icons and the positioning data. Since this is a CAD drawing, it does contain scale and distance information, and that is imported into EVAC, so we don't have to tell it any of that. Click on OK, and then if I check to show the floor map, we can see that floor map that we just imported from the CAD file. If there was a reflected ceiling plan that we had, we could enter that as the ceiling map. We could go into this area and right-click and edit it or remove it. Since we're not going to use it for anything else, I'm just going to click Remove, and we'll get rid of it. Now let's get into actually drawing our room model. I'm going to zoom in just a little bit on this using that magnifying glass with the plus icon. Now this image that we have in the background, even though we imported a CAD file, it's seen as in EVAC as just a background image. We still actually have to draw our 2D plan drawing. And we can modify our default room by dragging these little vertices at the corners. We have a vertex at each corner, and we have a virtual vertex in the middle. What I'll do to start out is I'll grab that virtual vertex, and as soon as I start to move it, it becomes a real vertex, and two new virtual vertices are inserted in the new walls. We can just grab these and move them around and basically trace the layout of the background image that we have in our model. I'll grab this one in the middle and pull it down here to the corner of this back section, take this virtual vertex, grab it, move it to that corner, and one more time with this one, putting it right there. So with just a couple of very quick mouse clicks, drags and drops, we've got a fairly complex room drawn with minimal effort. Now since we've done that, let's save that file. You can go to File, Save As, and we're going to save it as our system sensor assembly room. This will let us recall it at any later time when we want to make modifications. Now we're going to go look at the sound sources. We can see that we have several loudspeaker systems already in this room as part of the auto arrange function. I'm going to change these from the SP loudspeaker to the SPV. You'll notice that in the preloaded database for EVAC, there are several system sensor loudspeakers that come already included. Now this loudspeaker system that I selected is highlighted in orange over in the room model. I can also change multiple loudspeakers at once. I'll select the topmost one that I want changed. I'll press down the Shift button on the keyboard and select the bottom one, and be able to select multiple loudspeakers at once. I could then right-click and click on Properties and bring up the properties for all those loudspeakers. And I'll change them all to SPV at the same time. Now let's look at an SPL mapping. If I click the Show Mapping button, the engine in EVAC will immediately start mapping the SPL of the loudspeakers. Now right now we're looking at the direct SPL. The Z denotes that there's no weighting applied to this. We can also choose a weighting if we'd like, and I'll change to that. You'll notice that we could also look at the total SPL, which would include reflections from all of the room surfaces. But we're just going to look at the A-weighted direct SPL for now. Right now we're looking at a bandwidth of 3 octaves centered at 1 kilohertz for this SPL mapping. We could also change that to broadband, so it looks at the entire frequency spectrum. Now, there's not a whole lot of difference when I change to that, but we'll just leave it as broadband for the rest of the presentation. Now if we look at our actual SPL map, upon initial inspection it might not look too good. It looks like there's a lot of variation here. It's a lot of red right under each loudspeaker system, transitioning to yellowish orange and green or blue where there's not some loudspeakers placed. But if you'll notice, we have kind of a compressed SPL map, or a compressed legend for our SPL map. It's ranging from about 69 dB up to about 77 dB. So we've only got an 8 dB range for our entire SPL map. If we were to click on this area, it's going to automatically open our options dialog box to the mapping area. And you can see that our SPL is set to scale automatically just to our upper and lower limits. I'm going to uncheck that for just a minute so that you can see it, I like to call a little more clearly. We'll go from 90 dB to 60 dB, so we'll have a 30 dB display range, and click OK. And now it looks like we've got a lot more even coverage in our room. I think we do. If we put our cursor close to directly under one of our loudspeaker systems, and I'll move it momentarily, if you look in the status bar down in this area where the cursor is now, you'll see that the SPL is about 77 dB. If I move it to the middle of some of the loudspeakers, it's about 75 dB. So we've only got about a 3 dB deviation from the farthest away of any of our loudspeakers to directly under it. So that, I think that's pretty good in terms of the overall level change. Now, is this enough SPL for us? Is the mid-70s loud enough for this particular application? We want it to be a little bit louder. So one of the things we can do is change the tap settings. I'm going to go over here to Auto Arrange to do that. And you'll notice that Auto Arrange is now unchecked. It's unchecked because we manually made some modifications to these loudspeakers. We changed them from SP to SPV. Anytime you make modifications to the loudspeakers on this Sound Sources tab, Auto Arrange is automatically going to be unchecked. We'll check it again. You can see it picked up that we now have SPV loudspeakers everywhere. But we're going to change our tap setting on all of them. We're going to change from 1/4 watt to 2 watts. And you can see the SPL map updating immediately as we enact that change. Now right under a loudspeaker, we're a little over 85 dB, close to 86 dB. So now we're in the mid-80s, which I think is going to be loud enough for what we want to do. Now let's go over and look at our distribution tab that I mentioned briefly in the introduction. What the distribution tab tells us is what the SPL is over what percentage of our room. Right now we can see that we have 84 dB SPL in over 45% of the audience area. Now each bar in this bar graph is 1 dB wide. It goes from a 1/2 dB lower than 84 for where I am now to a 1/2 dB above 84. This 1 dB is called our class width. If we wanted higher resolution in our class width, we could go to 1/2 dB, and then we'd see the SPL distribution at 1/2 dB intervals. Similarly, we could change it to a 3 dB class width. So now we can, by analyzing our distribution graph set up with a 3 dB class width, we can say that we have 84 dB over almost 76% of our audience area, plus or minus 1.5 dB. You might wonder where I'm getting this 75 or 76%. Again, if you look at the status bar in this area, while you're hovering the cursor over the distribution graph, you can see the actual percentage. It makes it a lot easier to read.
You can also click on the bar, Charlie.
Thank you. So we can click on the bar and that'll show the SPL, or excuse me, the actual distribution over those sections. Now let's look at speech intelligibility, or STI. Now you'll notice we can also map this in Alcons or CIS. There's a straight equation to convert between all these that EVAC can use, but we'll look at STI. Now we see a really dark red coverage over our audience area, and we can see that this is an STI of less than 0.2, which is not very good. We also notice down here in the lower right-hand corner of our status bar that we have 10 warnings. So if we click on that to investigate, it tells us that these are warnings having to do with surface materials, that no main material has been assigned to, in this case, any of our walls or the floor or ceiling. Not assigning any materials is going to yield an unreliable STI result. So that's why we get the warnings. So let's go over here to our Surfaces tab. And we can see that on the floor, if we click on the floor, we don't want to click on this plus sign. That does something that Bruce is going to cover later on. But if we just click on the main material, we see that it's a hard wall. And the absorption coefficient is 0. The default wall material for any surfaces in EVAC is going to be this hard wall, which is basically an acoustical mirror. and give us the absolute worst intelligibility results we could get. So we have to manually go in and assign the actual materials that are going to be used in this space. I'm going to expand this selection box a little bit so we can see it a little bit better. Now for the floor, we're going to use carpet that's on a concrete floor. I can hit apply for that, and EVAC will immediately start recalculating the STI. For our ceiling material, we're going to use a suspended lay-in ceiling that has an overall noise reduction coefficient of 0.5. And I'll apply that. And again, EASE will automatically begin updating the coverage map. All of our walls are going to be a single layer of 5/8" chipboard on studs. So I can select that. Now all of our walls are going to be the same material. So just like we did with the loudspeakers, we'll select the first one, hold down the Shift key, select the last one, and select our one layer 5/8 chipboard on stud and apply that. And since we've made quite a few changes, I'm going to save the model again. Now we can see that we have an STI of just under 0.7, about 0.67 over a majority of our area. We'll change our class width to something a little bit higher, maybe not that high. And now you can see what the STI is over the majority of the coverage area. Now one of the things we can also do with EVAC is look at the reverb time in the room. If we go over here to the room tab and we click on the settings button next to reverberation time, we can see a plot of the reverberation time in seconds versus frequency. Now this is based on a statistical calculation that EASE Evac has done using the Eyring equation. If we had actually been in this actual space and taken a measurement of the reverberation time in the room, we could input that manually and override the internal calculation. To do that, we could click on Manual Input, click on Import, and actually import our reverb time file that we had exported from another program. Let me select a measurement that's about 4 seconds. Actually, this is not actual measured data, but it'll show the point. And I'll click OK. And because of the increase in reverberation time, we immediately see a drastic reduction in STI. We go back to the calculated reverb time in our model. We'll again see the STI go back to what it was when we had a moment ago. Now noise will also affect the speech intelligibility within a space. And EVAC can take that into account. If we click on the settings button next to noise levels, we can see that for the calculations that we've been looking at so far, there's a broadband background noise of about 50 dB. Now we can look at that in 1/3 octave frequency bands and see that they're just under 37 dB at each 1/3 octave. With broadband, that's going to give us 50 dB. Let's say we had higher background noise. Maybe there's a noisy air handler or something in the space. Let's import an NC70 curve. Now let's do an NC65. Now we can see because of that increased noise, our STI decreased a little bit. It's not a huge difference, but there is a little bit of a difference. If we were to go back, and in this case, let's import NC45, now you can see the STI improving again because of the lower background noise. One of the other things I want to show is the auto arrange feature. and how that can be useful for auto-arranging some of the loudspeakers.
Hey,
I'm going to
Charlie.
take off the show mapping momentarily to make this go a little bit more quickly. You can choose between a hexagonal layout, as you can see how that changes the spacing of the loudspeakers, or a square layout. We can also select between edge to edge, which we have right now, a minimum overlap, which puts the loudspeakers closer together, or a center to center, which puts them even still closer together. We want to go somewhere in between the center to center and minimum overlap. If we can notice that our distance for minimum overlap is a little over 24 feet. For center to center, we're a little over 17 feet. We're going to split the difference and go about 20 feet for our distance between loudspeakers. And this is the pattern that we get. And it's not too bad. There are definitely some loudspeakers over here closer to the side wall than we would like. So we can use our fine-tuning section to actually move the entire grid over. We want to slide it over to the right a little bit. So if I increase that X offset, you can see how it slides over. We're going to slide it over about 10 feet. And now that's centered up a lot more nicely. Front to back, I think that looks pretty good, so we'll leave it there. If for some reason our grid or our room was actually rotated compared to our layout, we could actually rotate this. I'll enter 30 degrees for an offset angle, and you can see how it just actually rotated it. It actually looks more like a hex pattern now. Let me decrease that to about 10. Now you can see a little bit more accurately how everything's just rotated. We'll take that back to 0. So everything should be lined up squarely. At this point, I'm going to turn it over to Bruce, who's going to show you some other features of EVAC.
Charlie, we do have a couple of questions posted. Could we take those at this time?
Absolutely. It'd be a great time to do it.
Okay. The first question is, can you move individual speakers?
That's a great question. Absolutely. Yes, you can. Let's go over here to the Sound Sources tab. I'm just going to grab this one in the back. I'll click on it, and you can see it became highlighted in gray over on the right. I can take that, and I'm just holding the mouse button down, and I can drag it really wherever I want to. And I can drop it there. I'll put it back about where it was. You could also change its position by typing in the X and Y coordinates to move it as well. So we want to change it to the X of 0. It's going to move it right to the center line. And I'll move it back to about -7 feet where it was.
Okay, very good. Next question is, what are the noise file formats? So what noise file formats and reverberation formats do you support within EASE Evac?
I believe those are text file formats.
Yes, they're both text file formats that are relatively straightforward.
Okay. And
yeah, they have a specific extension, but you could open those in a text file editor to see the format and create those yourself.
Okay. And a related question, where do you get these noise files from? Do they come preloaded, or is that from a secondary source?
No, these noise files that I was showing to import actually come preloaded for EVAC. So you have all the different NC noise level curves, NR, PNC, and RC that you can select from. All of those are preloaded.
Okay. When you selected STI, there was a selection for CIS. Is there an occasion you'd pick one over the other, and does it matter from an intelligibility standpoint?
From an intelligibility standpoint, it does not matter. As I said, there's a straightforward equation that converts between STI values and CIS values, and that's done internally within EVAC. if you're working on a project that specifies intelligibility for CIS as opposed to STI, then it's probably going to be easier for you to work in CIS.
Okay. When you were bringing in the background images, the user or the attendee here didn't see PDF. Is PDF an option for importing background images?
No, that's a great question. I'm glad they brought it up. I should have covered that. PDF is not an option to import a background image. However, if the only thing you have is a PDF as opposed to an image or a CAD file, you can have that PDF image up on your screen and just do a print screen and save that to a bitmap using Paint or any other image editing program. And then you can open up that bitmap or PNG or JPEG or however you chose to save that, that file.
Okay, all right. This user has a ceiling that's 30 to 40 feet in height. Is this software capable of measuring acoustics within that space?
Yes, absolutely. That should not be a problem.
Okay. This attendee is familiar with your regular EASE software, and he's wondering if the materials in EASE can be imported into EASE Evac. Yes,
they can.
All right. And how about importing other materials into the EASE library? How would they go about doing that?
That's something that can be done, but has to be done with other software. If someone has EASE 4.3, the facility to do that using the materials database module can be used, or if they have SoundFlow, which is another AFMG product, that can be used to construct the wall materials and create various files that can be used in the database.
Okay, all right. Last questions, and then we'll move on to Bruce here. Does this program address sound transmission across construction barriers, so i.e. walls, or only within single enclosed rooms?
That's a very good question. All the predictions are confined to within a single room. There's no transmission through walls within EVAC. Everything within a room happens within that particular room. There can be no doors or windows in rooms that allow sound to leak out or in. Of course, you can put the windows in a room or doors in a room by nature of their wooden metal construction or glass construction to get the right acoustical properties of the room, but sound's not going to go through an open or closed window or a door.
Okay. At this time, we're transitioning to Bruce Olson, also with AFMG. Bruce, take it away.
Thank you, David. I'm working with the same room that Charlie started, but I've loaded my version of the room where I've done a little bit different loudspeaker layout in order to show a couple of other capabilities of the software. The architect just informed me that actually we don't have a 20-foot ceiling height in the back portion of the room. That's only 10 feet high. Originally only had a plan drawing from him. Now he tells me, oh yeah, that's right, I forgot to tell you. That's, of course, never happens to anybody but me, but at any rate, I need to now set these loudspeakers at 10 feet. So how do we go about doing that? Well, one easy way to do that is, having done the layout that Charlie had done, if we copy those loudspeakers, and I'm going to just use this selection tool up here, the second icon, and draw around all four of these loudspeakers that I have in here, I can now right-click on this and copy those loudspeakers. I'm going to do that so that I can bring them back in just a moment. What I'm going to do now is I'm going to go to first my room tab and change my overall ceiling height to 10 feet. And what that's going to do, if I go back to the auto arrange tab and switch it back on, is it's now going to give me all of these loudspeakers arranged automatically throughout the room. Now, what that does is it easily gives me a way to give me this distribution in the back here. And what I want to do is center these 10 or 12 loudspeakers that I've got here so that I get a nice coverage in the back of the room. And maybe if I increase my X offset by just a little bit, then I'm going to get something that looks to be an even coverage. So now what I want to do is I want to do two things. I'm going to get rid of all of these speakers here by selecting all of them and pressing delete. That's going to automatically turn off my automatic arranged sound sources, leaving these guys at the back of the room. The second thing that I want to do is I want to then paste back in these other loudspeakers that I had, and I'm going to do that by just doing a Control V for paste, and that's going to copy them in, and then I can drag them into the center of the room. Now I've got a layout that's done at 20 feet for these loudspeakers and a layout that's done at 10 feet for these loudspeakers. Now the other thing that I want to show is Charlie mentioned that you could select properties, and you can right-click on this selection and select properties with just press F4. And here you can see now that that dimension of those loudspeakers for the Z dimension is at 20 feet, which is where they were originally. If I come down and select this other group of loudspeakers down here at the back of the room and do the same thing, press F4, I get the dialog box for those selected loudspeakers where you can see those are all set at 10 feet. So I could if he comes back and says, oh yes, that's right, those are now at 12 feet, I can come through and change the dimension of the ceiling height of those loudspeakers to 12 feet. So this gives us a way to deal with different soffit heights in a room, different sloped ceiling height, where we can work from the front of the room that has a high ceiling to the back of the room that has a low ceiling. We can use the automated tool to help us very quickly determine what the spacing might want to be between these loudspeakers, and then we can put the loudspeakers in at the appropriate loudspeaker heights. The next thing I want to show is in Charlie's overview, he showed that you could create a receiver location and get a frequency response at a location. We do that by selecting this Add Receivers button up here, and now I can place additional receivers throughout the room at a number of different places. You see, as I place them in the room, it adds them to this frequency response drawing down here and allows us to take a look at what the frequency response is in multiple locations. It also gives us the mapping value at each of those locations, and that mapping value corresponds then to whatever our mapping parameter is. In this case, I've still got STI selected here. So we're looking at STI at specific locations in the room. I can also move this loudspeaker and tell it to, by right-clicking on it, I can move it over to on axis of this loudspeaker. If I then click on that in the lower frequency response, now I can see that its frequency response is flat, and I can see the variation of the frequency response to my receivers throughout the room. And I can move them around the room and see what the variation is. I can even look back here in the back of the room where it looks like I've got some more low frequencies than I do up in the main part of the room. The next thing that we want to take a look at is adding some surfaces, this plus button that Charlie mentioned. So I'm going to go to the Surfaces tab down here on the left, and I'm going to take a look at my main material, which Charlie had said was commercial carpet. What I've done is I've added 2 additional areas by using the plus button. Let me remove them momentarily by pressing the delete key. So here we can see that my overall surface area is 8,400 square feet or so. By clicking the plus button, I can add an audience area. I happen to know that the main audience area in the front is 5112. 5,112 square feet. So by entering in the value here, it's going to subtract it from the total and then put back under the main material what remains from that total. I've got another part. I need to include also the audience area that's in the back of the room. So if I press the plus button again, I can say, I can take a look at the audience area in the back of the room, label it that way, and I happen to know by measuring off the plans that is 997.5 feet. And when I enter in that value, it subtracts still some more from the main material area and gives, so the sum of these three values should still be 8419. And now I've divided up the surface in the room to be my audience areas. Now it's defaulted to this hard wall again. So if I select both of these materials by clicking on one and then shift clicking on the other, I can come down and say, I want to put people in wooden seats in that area. And now I can take a look at what the differences are in STI for adding an audience to that room. I could change the types of audience. I could put in part of the room and so on. So this gives me a way of investigating what happens when I have people in the room. The next part that I want to show is I'm going to open another project here, and I do want to save the changes of that project, and I'm going to open up a project that I worked on a few months ago, which shows multiple rooms in one drawing. So if we take a look at the Room tab, here is the floor map of the 104th floor of the World Trade Center, which has got a number of acoustically distinguishable spaces in it. And so I'm, in this case, using my rooms to map all of my various ADS spaces. And one of the things about ADSs is that is typically used particularly when there are walls between the rooms, like there are in this case, where I've now got multiple rooms all separated and they all have separate loudspeaker systems in them. You can see that I've got a variety of different mapping colors on here. I have a couple of them that are, if I hover over down here, you can see down in the status bar, down here again, that my STI in this area is in about 0.39, 0.4, 0.41, something like that. So the original design that I have for this room is probably not adequate. I'm going to have to do something in this room. Same thing up here. This one's slightly better, but it's still not going to meet my STI criteria of 0.5. And so I'm going to have to add more than one loudspeaker in these rooms. One of the reasons why these rooms are a problem is if I take a look at the surfaces in the room, I've got all gypsum board, but it's a concrete floor and a concrete ceiling because these are mechanical areas. These areas, on the other hand, are in much better shape because primarily they've got suspended ceilings and carpeted floor, or this one has a concrete floor, but other spaces have carpeted floors where my STI is much improved. The other reason for taking a look at this one is that here I have, first of all, my list of all of these rooms that are entered in. I didn't change them from the default names, but I have a very quick way of getting between the rooms by using control keys. So here's room number 1, here's room number 2, here's room number 7. And by doing that, it automatically zooms me to that room and shows me all of the loudspeakers in that room. In this case, I have 2 loudspeakers. They're mounted on the wall. How did I get the loudspeakers mounted on the wall? Well, EASE Evac allows you to use speakers either as a wall mount speaker or as a ceiling mount speaker. It's dependent upon the specific speaker whether or not it should be used for either floor or wall or ceiling, but in this case I'm using the I think it's SPSC in this room. So if I select this wall and take a look at the front view of that wall, I can now see my loudspeaker on here. I can select the loudspeaker here, and you see, let me zoom in. Hang on a second. Let me zoom in to this loudspeaker here on the wall. You can see the icon for it on the floor plan. And when I take a look at this wall mounted, or if I click on the wall and look at the front view of the wall, I can see my loudspeaker over here on the left-hand side of the wall. And if I right-click, I can take a look at the properties. I've mounted it at, well, I guess I didn't change this one, 8.5 feet is where I've mounted all of these loudspeakers. I've got the same set of settings that I've had previously in that Charlie showed you for the ceiling loudspeakers. I have a similar thing for the wall-mounted speakers. I still have a horizontal vertical rotation for the orientation. Here I have a distance from the left-hand side of the wall of 4 feet and a distance from the floor of 8.5 feet. I have the same ability to set tap settings as necessary and so on. So here I'm looking at the coverage of this loudspeaker from an STI perspective in the room. Last thing that I want to show with this model is creating a report. One of the things that once you've done a complex model like this, now you need to report the results and show what's going on. We have a very quick way of creating a report using the data in the project, and we can create that report as either a PDF file, which we're going to look at, or as an RTF file, which can be opened up in Word and combined with other items that you need to report, or you can combine multiple maps and so on. So the RTF gives you a way of modifying it in Microsoft Word, and PDF gives you a very quick output of a PDF file. I've already generated this PDF file, so we're going to take a look at it here. And wait a moment while I have to press.
You're on the save dialog box from the report.
Yep. Hang on. If I show you this, there we go. Now you should see the PDF. Is that right?
Yep.
Okay, good. So here is the beginning of the report. It's got a little title at the front. This is World Trade Center. Actually, it's World Trade Center Floor 104. It gives us all of this information that we entered on the project information. If I had typed in notes, those notes would show here as well. It gives me a summary of all of the sound sources that were used in all of the rooms. I've used one SPS, a couple SPS-Cs, a couple SPS-CVs, and 8 SPVs throughout this project. I can take a look at the overall layout where I can see all of my room names showing here on the overall layout of this floor. I've got 11 rooms in here. And then I can also go down and look at what a typical room's report looks like. Here's room number 7. This is what we were looking at before in EASE Evac. Here are my 2 loudspeaker locations. Gives me my mapping levels of STI. Gives me my room height, my ear height, what network voltage was used, how much power was consumed by the loudspeakers that are in the room. They were both at quarter-watt taps. Tells me about the locations of all the vertices in the room, the reverberation time that's in the room, and then where are the sound sources? Where are they located? What were their tap settings? What was the distribution for the room, standard deviations, all of that information, as well as the 3 locations of my receivers and what the frequency responses were at those locations. So we get similar data for each of the rooms printed out one by one as we go through. Let me come back to, let's see here. Let's switch this back again to here, I believe. And now you should see EASE Evac again. Hopefully, if I've done it correctly.
Yes, we do.
Great. All right, next up is to look at some more advanced techniques, and we're going to do that by opening, actually starting a new project again. I don't need to save that. I'd previously saved it. And I'm going to turn off mapping. And I'm going to cover a couple of room layout things that Charlie did not cover. So I'm going to go and select the floor map here, and gives me this load layout map where I've got a variety of different CAD files. Now, one of the things that we can import is EXF files from AutoCAD or Sketchup files from Google Sketchup. I'm going to load in the same assembly room that we had here, but this time I'm going to load in the Sketchup file version of it and take a look at what we're allowed to do with this one. One of the things that we can do is we know what the scaling is, just like we did for the EASE project that Charlie loaded earlier. And so there's not much that we need to change in this dialog box. If we have an origin, and this can happen in a SketchUp file where the origin is off over here by 4 or 5 miles, we can shift the origin to a specific location in the drawing. This just makes the dimensions relate to the actual room that we're in rather than relating to someplace over on the project site that's a couple of miles away. So we can do that by entering in different values here for the X and the Y coordinate. The other thing that we can do is we can cut points above a certain height. So in this case, I've got some ceiling panels that are shown in the room, and I can set this cut height to be 12 feet, and now I no longer see those ceiling panels that are in the room. I only see the floor plan part of the room. So I've got a 3D drawing that maybe has some things that are obscuring what I need to see in the floor plan. I can use this cut points above to restrict the height of this floor plan that I'm going to look at. The second one I'm going to look at is I'm going to load in the same drawing, but now I'm going to bring in the AutoCAD version of that drawing. Now, in AutoCAD, we have yet one more thing that we need to deal with. In AutoCAD, the units that might be used vary depending upon where the drawing's source is. So in the U.S., it's usually U.S. architectural units, which for AutoCAD is something that displays in feet and inches, but is actually measured in inches. And so the scaling factor between meters, which is what our raw data format is, and feet and inches is actually a scaling factor of 0.08333. Now, if I were working in meters, it's more commonly that I would get a drawing from AutoCAD that was either in millimeters or meters. We also include centimeters because we've seen that as well. But if you are working in U.S. units like we are today, then it automatically assumes that the AutoCAD drawing is going to be in U.S. architectural units. If we had been working in meters or SI units, then it would automatically scale to meters, and then you could choose meters or millimeters depending upon what the drawing is drawn in. You can also, if it's drawn in something completely different, enter in any arbitrary scaling factor, and this is done by choosing the custom box. This scaling factor is then the scaling factor from the drawing units in the AutoCAD drawing to the EASE Evac units, which are always meters. This still has the cut points above. You can shift the origin here as well for the same reason that we do it in SketchUp, or we can automatically go to the center of the geometry for our 0, 0, 0 point. Given that this drawing has got the same origin as the SketchUp drawing, I'm going to leave it where it is. So here we can see, similar to what Charlie first started with, I can switch then between the ceiling map, which includes these ceiling diffusers, and the floor map where I had excluded those ceiling diffusers from that floor map. So this gives you a very flexible, very quick way of bringing in floor plans and being able to draw over them from a wide variety of different sources of plans.
Bruce, we have a couple questions posted. Could you take them at this time?
Now would be a great time.
Okay. They're wondering about EASE Evac's capability in determining speaker placement in large cavernous spaces. They're talking about large industrial facilities, ceiling heights of 40 feet or greater, maybe an aircraft hangar. How can you address that?
Well, let me remove these two plans that I've got here, and I'm going to go to just my default room that I've got here where I can say, okay, what dimensions do we want to use? So how long is this thing? Let's, aircraft hangar, probably, what, 400 feet long? Sure.
It's your guess, so sure. They don't specify. They actually said they're doing a space 1.1 million square feet in industrial space.
Okay. Well, let me try this, and let's see what we end up with here.
I think the question is more about just huge spaces, tall ceilings. How would
so we're going to put in a 60-foot ceiling height here. Our ear height is going to remain the same. Let me zoom into this overall thing. So here I am now, a room that is 400 feet wide, 600 feet long, and we can take a look at the mapping of this. And let me see. Auto arrange, I'd better use at least this. I better use that. And in this case, we're probably going to have borderline levels as using the SPV. I think that's the highest power one, isn't it, David?
Yes.
So our levels here are roughly 73, 74, somewhere underneath the speaker, about 72. One of the things that helps in these spaces is by increasing the number of loudspeakers, we see that our variation goes down as well as our level goes up. So one of the things that we can do is to go to, rather than using edge-to-edge, which works just fine in a smaller room, we may need to go to a minimum overlap or a center-to-center overlap. Now, the other thing that often happens in these rooms is that they may be a 60-foot ceiling height, but in certain areas we've got places that need to be dropped down, or we may actually have pendant lights hanging in there. The actual loudspeakers may be hanging somewhat below the ceiling. We can do that again by selecting all of the loudspeakers, pressing F4. Right now that defaults to our 60-foot ceiling height. Perhaps though, because of ductwork and everything else that's up there, perhaps those loudspeakers can be hanging down at 50-foot ceiling height. And if I do that, then it will give us a mapping for setting those loudspeakers at that different height. Now, if I want to automatically arrange it like I did before, I can temporarily set that ceiling height to 50 and then use the auto arrange function as well.
Okay, good. Bruce, the next question is on your report that you showed.
Yes.
Does the report automatically create the bookmarks in the PDF, or is that something that the user has to do?
No, that automatically creates all of those bookmarks that you saw in that PDF were automatically created by the program. The same bookmarks are created in the RTF version as well.
Okay. We have a number of questions about the cost of the software, the training that might be available, the after-purchase support. You want to cover that at this time?
Sure. The software is sold via our store website. It's the, let me see. Let me be adventurous here and go off. Enter in, hang on a second, my screen will appear in a moment once I get this moving. Let's see if I show this one. There we go. Now you should see my browser.
We do.
Great. So our website at evac.afmg.eu has got a purchase link at it that will bring you to the price list and online store. When you click on that, it will bring you to the store where EASE Evac is right here, 700 euros. And so the guys in the U.S. say, so, all right, what is that in U.S. dollars? Well, if we click on that and select the United States, we will then automatically give you the pricing estimate in U.S. dollars as well, which is about, oh, it's gone down, 847. I see the euro is declining. Last week when we did this webinar, it was 860. That's how you can purchase the software. It is an electronic download. We will send you a link to our download portal, which then gives you the ability to upgrade to the free upgrades, as Charlie talked about. We've done two releases, or actually 3 releases. The initial release, a bug fix update, as well as this feature edition version that we've released a couple of months ago. Support in the U.S. Is then handled by both Charlie and I. That is shown by going back here. There's our support page here. This phone number in the U.S. and Canada comes directly to Charlie and I. Whichever one of us is available will answer that. This email address here, which is on the slide that David will show at the end of the webinar, gets you to one of us, and we'll respond. Training, we did some training at Infocom this year. We are looking at doing some more training in the coming year. We've not yet scheduled any of those, but we expect to be doing more and more of these as the program is distributed more.
Okay.
And we'll do more webinars as well.
There we go. Good, good. A question here about the different types of EASE software. They're calling one EASE Focus, Standard EASE, and EASE Evac. What's the difference? Okay.
We've got actually quite a few products. As long as I'm here, I might as well show them. Quite a number of products. The ones near the bottom here are on the measurement side, EASE and Systune. On the prediction side, we've got a whole bunch of software. EASE is the general purpose tool that gives us greater capabilities along with greater effort, and it allows you to create the material files, for instance, that Charlie was talking about, and so on. And it is a general purpose tool that will calculate acoustics and electroacoustics parameters for a lot of systems. EASE Evac and EASE Address are pretty related. EASE Address came out a few years ago. It was just for ceiling loudspeaker systems. It does not do STI. It is a free software to the user and supported by manufacturers, and has a variety of different manufacturers of primarily commercial audio ceiling loudspeaker systems. EASE Focus is a similar free software for users, but it is targeted at the live sound performing arts center community. So people that are deploying line arrays and those kinds of systems are the ones that would use that. Again, it's supported by a variety of different manufacturers throughout the world. SoundFlow and Reflex are then small special purpose tools. SoundFlow, the most interesting one, in that if you don't have measurements of a wall material, it will predict what the wall material will be based on building up a wall boundary out of its tenant material. So 2 layers of gypsum board, a layer of fiberglass, and then a layer of 3 layers of gypsum board. It will give you the absorption coefficient of that wall construction. So hopefully that was a quick trip through. There's plenty of information here at the website to find out a lot more details about each of these.
Good. And Bruce is correct. We'll end with that slide and their contact information as well. Maybe one more question. We'll make sure we get the content covered here that you want to cover. Back to the report, for the power consumption in the report, are things like cables and transformers considered for power loss?
No, they are not. So right now we do not have a mechanism for calculating the lengths of the wire because one of the things we need to know is where is that equipment room. Actually, the amount of wire in the room is probably not very significant as compared to the wire that gets us to the amplifier room. So you'd still want to be able to calculate that separately. The transformers loss is taken into account by some manufacturers. Generally that's a quarter dB or a half dB typically, so it's something that I typically don't worry about, but it is not generally accounted for.
Okay. We do have a couple other questions, but let's make sure we cover your content, Bruce, and then we'll get back to those. Okay,
sounds good. The last thing, let's see here. Let me look at my list. Okay, so we've got we've covered multiple ceiling heights, some additional modeling techniques for very large projects. One of the things, one of the first projects that was used, and I'm going to open up yet another drawing or another file. Let me see here. If I go to Bogota, this is Bogota Colombia Airport. It's got some system definitions that have changed. That is, the GLL files that are used for the loudspeakers are different from what's in my local project directory, and so I can bring those in. Happens to have been, okay, some QSCs, I guess. And I have just a couple of rooms put in here, but here is the overall project. So when we talk about really, really large projects, this would be one that probably qualifies. This is 800 meters from here to here, from left to right, and 400 meters from top to bottom. And now when we get into a system like this, we've got a number of gates. Each of the gates have their own systems. Each of the gate waiting areas have their own systems. Each of the access areas to the gates have their own systems. So we can draw in all of those, but in this airport we have 4 levels. Obviously we can only do 1 level at a time, but we've got some 400 gates or so. So we want to divide this up. What actually ended up happening is that this was divided up into a number of separate projects. One of the things that we've done in the layout maps is allowed you to choose by default use same layout for all rooms. So we could do a project with multiple rooms with a single layout map for each room and assemble those all together. In a large project like this, when we're loading in 40 megabyte AutoCAD files, which is what the size of these files are, we get into a memory issue with all of those things. The project greatly slows down if we use separate layouts for each room. So one of the things we've done is gone to a common layout for all of the rooms, and this allows us to do some of these really huge projects that people are wanting to do. So here in this case, this was it's scaled to meters because this was done in Colombia and the AutoCAD drawings are done in meters. And the ceiling map in this case is actually what Charlie talked about. Here I've taken just a picture of the AutoCAD drawing, and then I can grab my A and B, and I happen to know that the width of this AutoCAD picture happens to be 800 meters, about 3,000 feet, and if I put that in there, then I'm able to see this layout in the same way that I can see all of the other layouts. One of the things that you want to do for a project of this size, though, is to probably divide it up into quadrants and do this quadrant, do this quadrant, do this quadrant. That's when the RTF report capability becomes really important, because then you can keep the project very responsive by not having hundreds and thousands of loudspeakers in it with 50 or 100 rooms, which does slow you down, but you can then combine all of them later. Okay, let's see. Where are we at? We're doing good.
And when you're ready for more questions, we have a couple more posted here.
I'm just looking through to make sure that I've covered everything that I thought we were going to cover, which basically we have. Let's go to questions.
Okay. Question on the predicted performance versus actual. Has the software output been tested compared to actual field installation measurements for SPL or intelligibility?
It has in the fact that it uses the same data that EASE does. That is, it uses the same calculation that EASE does, and EASE has been around now for 30 years, 20 years on the market, and there have been hundreds, if not thousands, of projects that have verified both SPL, STI, as well as a number of other acoustic parameters related to it. So it uses exactly the same calculation engine as EASE, its big brother, does, and those statistical calculations have been verified in numerous papers in acoustical societies the world over.
Okay, all right. One of the attendees noticed that you use direct SPL, the phrase direct SPL in some cases, and total SPL in others, and he's wondering what the difference is.
Okay, direct SPL is looking at just the level from the loudspeakers. Total SPL is looking at what is the SPL from all of the loudspeakers that are in the room. So here I have now done a total SPL map, and we can see that the levels are around 102 dB. And what that is and the reason for that is now I've taken the direct sound pressure level from this loudspeaker and added to it the sound pressure from all of the other loudspeakers in here. Because this is a default room, and because it has all extremely hard walls, then we're going to get quite a bit of reflection of that sound through to all of the other loudspeaker locations. So we get a much higher level. So the total SPL is the sum of all of the loudspeakers in the room. The direct SPL is just the sound from that loudspeaker going to its coverage area.
Another way to think about it, for the total SPL would be what you would measure in the room, including all the reflections from the wall and ceiling. The direct SPL would be as if there were no walls, ceilings, or floor anywhere. Basically the anechoic response from all the loudspeakers in the room.
Okay, good. The next question deals with obstructions that may be in the room, non-material or non-furniture type obstructions, like columns. And how does the software handle or address obstructions like columns?
Well, actually, thank you. That's the part that I forgot to do, objects. So we have on the objects page, which Charlie said Bruce would cover later, and now Bruce is covering it. We've got the ability to add both room objects and wall objects. I can't select wall object right now because I don't have a wall selected, but I've got a room selected. So in a room, I can add objects in that room, and I can add boxes that are mounted on the ceiling, boxes that are on the floor, same for cylinders, half cylinders, and so on, pyramid, a wide variety of different things here, or columns, which means that this goes from floor to ceiling. So I can put in a series of columns in the room, and here this one, it's going to go floor to ceiling automatically. So I've only got one dimension to put in here. My base dimension might be a 3-foot column, 3-foot radius, 6-foot column. And then I can choose how many of those are in the room. This is, oh, it's not that big a room, so there's about 10 of them in there. And I can enter in the value directly, and it's going to then put 10 columns from floor to ceiling that are 3-foot radius, 6-foot diameter. What's the column made of? Well, first of all, you get to choose what material on the floor it's covering. If I had multiple materials on the floor like I did in the model where I added the audience area, I would choose, is that column over the in the audience area, or is it in the side area where only the carpet was? But then I can also choose a material for this column. So here we've got some nice marble columns, and I can apply that, and now I've got 10 marble columns, 6 foot in diameter, that go floor to ceiling in the room. It does not actually place them in the room, nor do you have to place them in the room. Because we are using a statistical equation, we can take a shortcut which allows us to choose how many of these kinds of items do we need to put in the room, and it will automatically randomly place them in the room for you and then calculate the new acoustic parameters based on those being placed in the room. We can do a similar thing by selecting a wall. Here I'm going to select this end wall. And now I can add a wall object. So I can put a hanging wall. I can put something that goes from the floor and is attached to the wall, so on. In the same way, when I do this box that's on the wall and starts at the floor, I again can choose which material on the floor is it covering, which material on the wall is it covering, and then what is the size of this box, change the number of boxes on that wall, do a similar thing for other walls in the room.
All right, very good. Next question deals with the outdoor applications. Are there any outdoor applications? For example, maybe a playground at a school.
EASE Evac is an indoor application, really needs a room around it in order to be able to do that. Now, you could approximate it using EASE Evac by doing what I've done here, which is I've selected this room, gone to the surfaces of the room, and made them all really absorptive. And so now you see that my total SPL map is very near to my direct sound SPL map because I'm absorbing all of that sound that normally would have bounced off the walls. So you could do a similar thing with that. A more appropriate tool would be to use EASE, the Big Brother EASE for that.
Okay, good. The next question deals with absorption or transmission through doors. Does EASE Evac handle sound absorption / transmission through doors, like a wood or steel door? Does it account for that?
No, it does not. If it has to either treat the door as fully closed or fully open. If the door is fully open, then you would draw the room going through the doorway and include the space in the other space. That's usually not very useful because that doorway is probably shading you from getting sound through the doorway into some part of the other room. So it does not know about some sound leaking through and giving you some additional SPL and STI simply because the door is not very, or has a lot of transmission through it.
Right, right. Okay. Next question is, can they mix ceiling and wall-mounted speakers in a single room?
Absolutely. So here we've done an automatic layout here, and let's say that for whatever reason I cannot put loudspeakers down on this end of the room, something in the ceiling or whatever. I can then select this wall and then look at the front view down here and grab a sound source and apply a couple of loudspeakers on that wall. And then I can come to this wall and do a similar thing. Now, this is the front view of the wall. So to figure out where to put the loudspeakers, I'm looking from this direction towards this wall. So that means I need some loudspeakers someplace in this area. So I could put a couple here, and then I could go to the wall on the opposite side. Now I'm looking from this side, so the loudspeakers want to go over here. Now I have some level issues between these that I need to resolve, but you certainly can arbitrarily put wall sources in, ceiling sources in, mix and match as you'd like.
Okay, very good. A couple more questions here, and then we'll go to our close, and I will post that contact information as promised. They're asking about Autodesk Revit files, and will this be an option to import these types of files in the future?
We are looking at Revit. We don't have a schedule on that. Right now, what I do primarily with my EASE work is I export from Revit to SketchUp and then import the SketchUp file, and that works quite well.
Okay. A question on licensing. If you buy a single license on a desktop, could it be moved to a laptop if they're working mobily?
Yes, it certainly can. We have a licensing manager that allows you to upload and download the license. The license is actually held on our server, and you download a copy of that to the computer that you're working on. So you would first license it on your desktop, and then you would copy it. Then when you wanted to move to your laptop, then you would upload that license from your desktop and then download the license to your laptop.
Okay, very good. Well, I'm bringing up the EASE Evac contact information if people want to jot that down. Both Bruce and Charlie are available at that email address, the support-us@afmg.eu, and you also see a telephone number there for the U.S. and Canadian support, as well as other countries around the globe. We are at the 90-minute mark, and we did promise to start on time, stay on time, and end on time here. So on behalf of System Sensor and AFMG, I want to thank you for joining us today. As a follow-up, we will send you a brief survey in about an hour and would appreciate your help in filling that out. And we do plan to reward one of you that completes the survey with a $50 Target gift card. Once again, thank you for joining us. This does conclude our webinar. Have a nice rest of the day.